fasteners. Okay, when we talk about fasteners, we talk about things that hold parts together. So whether you're putting together something that's made of metal or made of wood or made of plastic, you may use any of these kind of fasteners, right? We have a common nail. You know, nails are for driving with a hammer into wood. We have some different types of screws. These are also for wood. They can be used for metal as well. And then we have an ordinary bolt like this or like this, which are common for attaching metal pieces together. We will talk about screws, whether they're used in metal or wood, where they're going to cut their own threads. We'll talk about those in another video. This video is only going to specify, or we're only going to talk about this type of fastener, which we call a bolt. Okay. The difference between a bolt and a screw makes its own threads in the material that it's going into. So when you put this screw into a piece of wood, you don't have any mating threads, or there's nothing in the hole to begin with. So you drive this in and it cuts as it goes into the wood. It cuts its own threads. Now, if you use this, a bolt is different than a screw. Screw cuts its own threads. A bolt has to have matching threads in the material it's going into. So if we have a piece of metal, if I have a piece of metal like this, and it has threads inside of it already, and I can take my bolt, and I can insert the bolt into the thread. So this piece of metal already had a matching thread. The pitch diameter was the same. The pitch was the same, so it fit. You could say, what about a nut? Well, if this nut also has a thread in it, and it fits as well. So the difference between a screw, it cuts its own threads. The bolt has to have threads already matching. We call these internal threads. We call this external thread. Okay. You may also hear it called male thread, female thread. We're going to use internal thread. The threads are inside the hole. External, the threads are on the outside. Okay. All right. Let's say your job as an engineer today is to find the dimensions of this bolt. Maybe this bolt was in a piece of machinery and it broke, or you need to replace it for some reason. And you need to know exactly how to describe this bolt. Well, there are many, many things we need to do. The first is we need to know the diameter of the bolt. So there are many ways you can do that. You could simply use a ruler and get a rough idea of the size. You could also use our good friend, the dial caliper, to be more accurate. I'm going to measure on the shank portion here. Almost exactly 1 inch, about 1,003. Or you can use a type of gauge like this. And I just find the appropriate hole that it fits into. One inch. Next, I need to know the thread size. These are the threads. These are usually mated together with other parts. There are a couple of ways that I can find the thread size. First thing you need to know is in a standard bolt, that's standard as opposed to metric. So in the US size of bolts, the way you measure threads is the number of threads in an inch. So if I take an inch measurement, and then I count the number of threads in that inch. 1, 2, 3, 4, 5, 6, 7, 8. 8 threads in an inch. or I can use a device like this. It's called a thread gauge. Basically, all of these little fingers that look like combs have different number of little baby teeth on them. See that? So what I want to do is each of these is numbered as well. You can see four of these. I'm going to simply match up the comb to the appropriate one. So this is these are really big teeth here. I'm pretty sure it's not one of those. Might be that one there. I'm going to take that one, and I need to match it up as close as I can and see if it fits in there. You see how that's not a match? Not even close. Okay, let's try another one. So I'm going to go over here. Try this one. You see, once again, not a match. Does not fit in there. Well, let's quit playing around here. Let's try this one. All right, here we go. Nope. That one, by the way, is a 9. So we know we're getting close. You see that match? Fits in there perfectly. Perfect match. Once I find the perfect match, I just read off. This one says 8. So I have 8 threads per inch. So now I know the diameter. I know the number of threads per inch. Now I need to know the length. So on the hex head bolt like this, we measure to under the head. We don't include this portion, so we just want to know the usable length here. And we have 8 inches. Okay, so now that we know the diameter, the thread pitch, the number of threads in an inch, so how close the threads are together, we can determine this bolt. We know the size of this bolt now. I do want to show you a couple of other gauges that I have here. So this particular gauge here is called the Gorilla gauge. It's really pretty unique. This one is for standard bolt sizes. So not only do I have that thread pitch gauge on there, but I also have the diameters. So I can find the diameter by simply taking a bolt and matching it to the correct corresponding hole. So this bolt is 1/2 inch. Okay. I also can use this for the pitch gauge. I want to find the number of threads per inch. Find that matching comb. That's not it. That says 11, 12. I can find one that says 13. There's a match. 13. So 1/2 inch bolt, 13 threads per inch. In the back, I can tell the number of the grade. Lower the grade, the softer the bolt. The higher the grade number, the harder the bolt. If you look at this chart here, you can see that there are 3 little tiny marks, dash marks on the head of the bolt. Would match this one. So that would be a grade 5 bolt, a medium hardness bolt. This is also a useful gauge. You see this came from Fasteners. There's a lot going on here, but we can use the different hole sizes in here to find the diameter of a bolt. So if I have a bolt and I don't know the size, I can just match it up until I find it, 1/2 inch. Then on the reverse side is that thread pitch guide. So again, you can, maybe hard to see here, but I'm going to use these little pitches here, and I'm going to match that up again until I find the matching thread size. This is also useful here. I can find the size of the nut. The nut corresponds to the thread size as well. So I can just place this on. It's too loose on there. Doesn't fit on this one. Fits onto that one perfect. So now I have a 1/2 inch. I can also use this to measure. There's metric on top here, inches on the bottom here. So again, if I was going to measure the length of that bolt, that is 3.5 inches long. Okay. There's some other thinner gauges like this that you can use. You can find these in a hardware store. Does the same thing. There's actually a little device on here for measuring pipe sizes as well. Some handy charts on the front and back. Lots of fastener information here. What if I have a little really tiny bolt? Can I measure that one as well? Sure. Let's take a guess on this one. Say this is about a 32. Perfect match. That's a 32. 32 threads per inch. All right. A metric's a little bit different. So let's talk about metric for a minute. Metric, once again, we're going to measure a metric bolt by measuring its diameter. However, instead of the number of threads per inch, TPI, threads per inch, we're now going to measure the distance from one thread to the next. So the way we specify a metric thread is pitch, and it's in millimeters. So I have another of the handy Gorilla Gauge here. So I can measure first the diameter of the bolt. So I'm going to find the corresponding hole part. It's a little too small. Let's go to the next one. Okay, found a match. That is a 16 millimeter diameter. So the diameter of the bolt is 16 millimeters. Now I'm going to use the pitch gauge again to find the thread pitch, or in other words, how close the threads are to one another. You know, you can have fine threads where the threads are very close together, or coarse threads where they're farther apart. Okay, so here's a match for that metric bolt. Let's put this up here. You can see, perfect match. That is a 2.0. So 2.0 is the number on the little tab here. That means the pitch is 2 millimeters from one thread to the next thread. So from one high spot or one ridge to the next ridge. That's 2 millimeters. So a metric bolt, again, we're going to measure the diameter, and we're going to measure the distance between the thread, but we're going to measure from one thread to the corresponding next thread. We're going to measure that in millimeters. Okay. Okay, let's talk about fine threads and coarse threads. So you might be asking yourself, why do we need this thread gauge if I'm just measuring the diameter of the bolt? Well, bolts of the same diameter can have different thread pitches. For example, you can see that I have 2 bolts here. And if you look closely, you can see that the one here that I'm pointing to has a coarser thread. In other words, the threads are farther apart. And this one has a finer thread. The threads are closer together, smaller threads. Now, I want you to see that these are both 16 millimeter bolts. This one is, and this one is. These are both 16 millimeters in diameter, but the threads are different, okay? That's the reason that it's important to use your thread pitch gauge of some type and to measure the threads, because it's possible you could get the right diameter but not have the right thread pitch, okay? That's why that's important. So we have a bolt. Talk briefly about the nut. The nut threads onto the bolt. This allows me to clamp pieces together. So whatever I put in between here and tighten this up, there is that inclined plane wrapped around a cylinder, which creates a mechanical advantage. As I turn this, it's going to increase the clamping force. So bolts are useful for holding parts together because as I tighten this, I squeeze what's ever in between here. I have 2 plates of metal in between there, and I tighten that nut up, it's going to squeeze those parts together. Now, a couple other things that we use commonly to go with the bolt is washers. 2 common types of washers are a flat washer. It has a mating hole in it so that inside diameter matches the bolt diameter. We also have a lock washer. This is a split ring lock washer. You can see a little notch in there. It also has the matching diameter. These washers have an important purpose. The flat washer is just used for spreading out the load. So if I put this into some soft material and I want it to be supported better, I can use the flat washer to give me more surface area underneath here to push down on. The lock washer with that little locking tab on there, used to prevent the nut from loosening. So if I tighten this up, and I'm just pushing against my fingers right now, but if I were to tighten this up with a wrench, that little notch right there actually takes a little bite into the nut and it prevents it from loosening. So it just helps hold the nut from loosening. Okay, next we're going to talk about the head of the bolt. That's where we're going to use a wrench or a screwdriver or a tool to tighten it. Okay, what do those look like? Those come in different sizes. I'm going to show you a chart in just a minute, but just as an example, some of these, this is a carriage bolt. So this is a carriage type head. So you can see there's nowhere to put a screwdriver or any type of wrench on here. That's for a decorative finish, so that when it's inside the material, you're not going to feel anything over that could snag. What happens though, this little square portion is going to get located into a square hole, usually punched into a piece of metal, so that prevents it from turning. The really most common one probably is this hex head. So it's a hexagon. We can use ordinary sockets and wrenches, a whole variety of tools that we can use to tighten that one up. There's called a round head. So if you look at that closely, it's just got kind of a rounded shape. This one actually has for a slotted screwdriver. There's also a button head. The button head is slightly shallower. So if you compare them side by side, this round head is going to have more spherical. This one's going to be more shallow, like a mushroom or a button on your shirt. And this is the flat head. That's going to give you another recessed surface. So when that's down into the material, there's nothing stick up above. And that has a cone-shaped head on it.